Alright, so continuation of this is going to be the last four pieces of your PowerPoint, last four slides. So last time we left off, we had getting from mass of given to mass of the unknown. Now we're going to go from mass of given to formula units of the unknown. Okay, so again, I'm going to go ahead just to refresh our memory. The chemical equation we had, or chemical reaction we had, was the Haber-Bosch process, which is 3H2 plus 8N2 is going to form 2NH3. So that's our chemical reaction right there with our molar ratios. And let's say I wanted I had 6.06 grams of H2. I want to know how many molecules of N2 would react with that 6.06 grams of H2. Okay, so obviously you guys can see that I'm going to make this math kind of easy just to speed us along. I'm going to take 6.06 grams of H2O, put it over 1, and then I'm going to use to go from mass, which is my given, to my moles of given, so moles of H2O, I'm going to use molar mass. All right, so 18.02 grams of H2O is going to form 1 mole of H2O. Now I am at H2O. What am I thinking? H2, excuse me. There we go. That makes a lot more sense since water is not even a part of that problem. So 6.06 grams of H2, and then this would of course change this to 1.01 grams of H2 per every mole of H2, or excuse me, 2.02. From there, I'm going to use molar ratio here. All right. And I know that I'm trying to get to the moles of my unknown. What do I want? I want N2, which means I want moles of N2 on top, and I put the moles of H2 on bottom, since that's what I have. I look at my molar ratio, 3 to 1. 3, 1. All right? So I'm not done yet, because I want to know how many molecules of N2. Well, I use Avogadro's number to go from moles to formula units. So for every 1 mole of N2, in fact, for any mole of anything, I have 6.02 times 10 to the 23rd molecules of N2, right? So now moles will cancel out of N2, moles of H2 will cancel out, grams of H2 will cancel out, and then I'm left with my molecules of N2, which is what I want in the first place. So, do the math real quick. Okay, so the product of my numerator is 3.65 times 10 to the 24 molecules of N2. Molecules of N2, a little run out of room right there, divided by 6.06. In both cases, I'm going to have 3 sig figs, so my final answer is going to be 6.02 times 10 to the 23rd. Okay, molecules of N2. Now you're wondering, well, that number sounds familiar. That's Avogadro's number. Well, yeah. If I look over here at my reaction, okay, 6.06 is going to be 3, it's the mass of 3 molecules of H2, or 3 moles of H2. Well, I already have 3 moles here, which means I should have 1 mole of molecules according to my reaction. That's why I ended up with 6.02 times 10 to the 23rd. Okay, let's go ahead and take a look at a different type of problem now. Now I'm going to go from formula units to moles. Okay, so I'm going to go formula units. When I'm going from formula units to moles, I need to use Avogadro's number. Okay, and then once I have my moles on my given, I can use molar ratio to get to what I want. Okay, so for example, same equation. What if I had 6.43 times 10 to the 24th molecules of H2? And I want to know how many moles of NH3 I can make. Okay? So, like I said, you'll have to refer back to your notes on the other page. But if I start with what I'm given, 6.43E24 molecules H2, put that over 1, right? And I know that there is 6.02 times 10 to the 23rd molecules H2 for every 1 mole of H2. And then I know that for every 3 moles of H2, I get 2 moles of NH3. How do I know this right here? That's the molar ratio. Okay? So let me erase that line so we can do some work. So if I do my math, so my product of my numerators is 1.29 e to the 25th. Okay, the product of my denominators is 1.81 times 10 to the 24th. I do that division. My final answer is 7.13 moles of nitrogen gas. Okay, so again, if I'm going from formula units to moles, I need to use Avogadro's number. If I'm going from moles to moles, I need to use molar ratio according to the balanced chemical equation. All right. So formula units to mass. So let's say I had, 4.36 times 10 to the 12th molecules of N2. I want to know what's the mass in grams of H2 that I would react with it. So if I'm doing that, I need to go from formula units to moles, which is using Avogadro's number. I will then need to go from moles to moles, which I'll use molar ratio, so the moles of my given to the moles of my unknown. And then my moles of my unknown to my mass of my unknown, I will use molar mass. All right, so start with what I'm given, 4.36 e to the 12th over 1. That should be molecules of N2. Right? And I know that there's 6.02, because I'm using Avogadro's number, 6.02 times 10 to the 23rd molecules of N2 for every 1 mole of N2, right? And then I'll use the molar ratio to go from moles of N2, which would be 1 mole of N2, for every 3 moles of H2. Where am I getting those? The balanced chemical equation. And then I'm going to go from moles of the unknown to the mass of the unknown using my molar mass. So 1 mole of H2 is going to be equal to 2.02 grams of H2. All right, and then I do my math. Okay, so my units all cancel out. I multiply my numerators. My product should be 2.64 e to the 13th, making sure I maintain my 3 sig figs. My denominator is 6.02 times 10 to the 23rd, again, maintaining my sig figs. And when I do that division problem, I end up with 4.39 times e to the negative 11 grams of H2, which is a very small amount of hydrogen gas. Okay? Last problem, or last type of problem, is going from formula units to formula units. So here, I'm going to use, if I'm going from formula units to moles, I'm going to use Avogadro's number. If I'm going from moles to moles, I'm using molar ratio. Same stuff. Okay, and then if I'm going from moles to formula units, I'm using Avogadro's number. Okay, so an example problem, what if I had 4.36 e to the 25th molecules of NH3, and I want to know how much hydrogen, how many molecules of hydrogen do I need to make that many molecules of NH3. Okay, so start with what I'm given, 4.36 e to the 25th molecules of NH3, put that over 1. Okay, I have 6.02 e to the 23rd molecules of NH3, right? Avogadro's number, for every 1 mole of NH3. And then I look at my molar ratio for my equation. I should end up with 2 moles of NH3 for every 3 moles of H2. And then I convert my, that's what I was using molar ratio right there. Now I'm going to use Avogadro's number again to go from 1 mole of H2 to 6.02 times 10 to the 23rd molecules of H2, and of course that's what I want. So here's what I want. My moles of hydrogen cancel out, my moles of ammonia cancel out, my moles of, or my molecules of ammonia cancel out, leaving only with my molecules of H2, which is my final destination, right? So when I do my math, my numerator is going to be 7.87 times 10 to the negative, 7.87 times 10 to the 49th. My denominator is going to be 1.2 times 10 to the 24th. So I'm going to go 7.87 times 10 to the 49th divided by 1.20 times 10 to the 24th. And I end up with 6.56 times 10 to the 25th molecules of H2. So it would take 6.56 times 10 to the 25th molecules of H2 to form 4.36 times 10 to the negative, or sorry, times 10 to the 25th molecules of NH3. Now, I'm sure you, if you look, you can find a shortcut here. If you want to know what it is for this particular problem, this type of problem, you're welcome to ask me. But if not, just follow the rules. Okay? Formula unit, moles to and from, I use Avogadro's number. Moles and moles, I use molar mass. And moles and mass, I use molar mass. Okay?